These are notes from section 2.4, which is on using postulates and diagrams. Using postulates and diagrams, should have a handout that has a lot of this on there. So not a ton to write down today, but you do want to kind of follow along, be thinking through the problems as we talk through them. We have a whole list of point, line, and plane postulates. These aren't anything you'll need to remember. I think it goes like 5 through 11. These aren't anything you need to memorize, rather. So you don't need to memorize that. Postulate 5 says through any 2 points there exists exactly one line. But you should understand what this is saying and understand that it's true. So if I have 2 points, no matter where those 2 points are, here and here, there is only one line that passes through those 2 points. It's not the straightest line, but that is the only line we can draw that passes through both of those points. So through any 2 points, there exists exactly one line, one and only one line. A line contains at least 2 points. In order to have a line, there must be 2 points, at least 2 points. There could be more. We could have 3 collinear points on the same line. We could have 4 or more than that, but we have to have at least 2 points to define that line. That is postulate 6. Postulate 7 says if 2 lines intersect, then their intersection is exactly 1 point. So if I have 2 lines, and I understand those look like segments, let's assume they're lines. If I have 2 lines, there is only one intersection point right there in the middle. Let's make them lines. So if 2 lines intersect, they intersect at exactly 1 point. They don't have to intersect. It's possible we have parallel lines, but if they do intersect, their intersection is at a point, 1 point. Postulate 8 says through any 3 non-collinear points, there exists exactly one plane. So this one's actually pretty similar to through postulate 5, through any 2 points, there is one line. Well, through any 3 points, as long as they're non-collinear, so they don't line up in a straight line, there's only one plane. So if I've got a point here, a point here, and a point here, that plane that passes through all 3 of those, there's only one plane. I'm not the best with drawing it, but it looks something like that. That this is sitting on that sheet of paper that extends forever in each direction, as is this and this, and that's the only plane that passes through those points. It is important that those points are non-collinear. If they do line up like this, well, we could take that sheet of paper and line it up here, right? But then I could also spin it on the line that exists here, like spin this, move that part over, and like take this part and rotate it down this way. Basically, those same 3 points would have, that's my drawing skills are not great. But if I spin it on that line axis, it's also going to pass through those 3 points. So there are more than one planes that exist passing through 3 collinear points. But if those points are non-collinear, that sheet of paper that's lying and passing through all 3 of those, there's only one that is going to capture all 3 of those points. And again, we know planes extend forever in each direction. Postulate 9 says a plane contains at least 3 non-collinear points. And again, this one kind of matches up with postulate 6. A line is defined as having at least 2 points. Well, a plane has to have at least 3 non-collinear points to define that plane. Could, again, have more that are sitting on that same plane, but there needs to be at least 3. Postulate 10, again, kind of similar to postulate 7 here, says if 2 points lie in a plane, then the line containing them lies in the plane. If 2 points lie in a plane, so we've got a plane, this plane right here. These 2 points lie in the plane. Then the line that connects them is also sitting on that sheet of paper, right? On that plane. And postulate 11, and this is the one I thought was coming. When I said this one's similar to postulate 7, I meant postulate 11 here. If two planes intersect, then their intersection is a line. And because I am so bad at drawing planes, let's take a look at what we're talking about here. So we've got two planes, one here, plane Q, and this red one, reddish-orange one is plane P. Notice the points that those intersect are all these points right here. That's where those cross. And remember, these planes are extending forever in each direction. Notice those points, all those points where the two planes intersect, all line up on a straight line. The intersection of two planes is a line. So those are, what do we have there? 7 different postulates about planes and lines. And again, you don't need to memorize, well, postulate 9 says this, and postulate 5 says this. But hopefully as we talk through those, all those things made sense. Those are things that you should understand that are given and understood to be true. So example 1, and these figures didn't turn out real good, but you do have them on your handout. Example 1 asks us to state the postulate illustrated by the diagram. So it's saying if, and then it looks like we have 2 lines that intersect, then we have 2 lines that intersect, and it shows that point there. And again, you can't see it real great, so I'm going to make it better. So it looks like it's saying if we have 2 intersecting lines, then maybe those lines intersect at a point. If 2 lines intersect, then their intersection is exactly 1 point. So this is going to be postulate 7. Part B says if, it looks like we've got 2 planes, then we've got 2 planes that are intersecting in a line. I believe that was postulate 11. If 2 planes intersect, then their intersection is a line, postulate 11. The next thing here is a definition. It says that a line is defined to be perpendicular to a plane if and only if it intersects the plane in a point. So it needs to intersect at only 1 point. It can't lie on that plane. And is perpendicular to every line in the plane that intersects that point. So notice this line is in the plane and intersects that point there, and notice that line is perpendicular to line L. This line here lies in the plane and is perpendicular to line L. If we were to draw another one like here in the plane, that line would also have to be perpendicular to line L. Every line in the plane is perpendicular to line L. That is the only time we would have a line that is perpendicular to a plane. It needs to intersect it at 1 point, and it needs to be perpendicular to every line that lies on the plane that passes through that intersection point. The next set of problems, example 2, and it's a big example with a bunch of parts to it. It gives us this figure, and this figure has a whole bunch of points. It's defining J as that intersection point right there, H as the intersection point here. This is plane P. And it wants to know, based on this figure, only the things that are told to us in this figure, which of the following can be assumed. So when we're looking at a figure, we can only assume things that are given to us. We can't say, well, AH looks like it's about the same as BH, therefore those distances are the same. They would have to do something to tell us that those distances are the same. And typically they would put 1 tick mark through each of those to say this distance and this distance are the same thing. Same with like angles. We can't say like, well, this angle here and this angle here look like they're close to each other. Therefore, BHJ and CJD are congruent angles. We can't do that because they don't tell us that those have the same measure. And they might be close to each other, but we don't know for sure that they're the same. They would indicate they're the same by putting a line or one little thing there to show this and this are equivalent to each other. So this is asking each of the following, can we assume this based just on what we have? So G, F, and E are collinear. G, F, and E are collinear. You decide if that can be assumed or not. And it sure looks like they're probably collinear. But based on what they tell us, we can't say they're collinear. Had it given us A, H, and J, we can say those are collinear because we see the line that passes through them. They did not draw a line through G, F, and E. This figure might not be to scale. G might be down here a little bit. It might not line up perfectly collinear with F and E, or F might not line up collinear with G and E. So we cannot definitively say that those are collinear. Part B says line AD and line BF are perpendicular. AD, so this line here, and BF are perpendicular. It actually doesn't even look like they are, but even if it looked like they are, we can't say that for sure. I don't know what these angles are. This one looks slightly obtuse, and this one looks slightly acute. If they were to want those to be perpendicular, they would have to tell us they were perpendicular by drawing the perpendicular right angle symbol right in there. C and D, same figure. BF and CE intersect. BF and CE intersect. They might be parallel. They might intersect way down here somewhere. It looks like this one's kind of coming in this way and this one's coming in this way. They could intersect up here because these aren't drawn to scale. And this one's actually the going this way and this one's coming this way some. No, we cannot assume that those intersect. But we also can't assume they don't intersect. They might be parallel to one another. Something would have to be given to us in order to show that those are parallel. And as we move forward, we'll talk about a lot of different things and ways that we could prove that those are either parallel or not parallel. But based on what they give us here, we don't know anything about these angles in here. We cannot say that those lines either intersect or that they don't intersect. Based on what's given to us, they might not. Part E, all points shown are coplanar. They all lie on the same plane. Yeah, that's true. AHB and BHD are a linear pair. AHB, I don't know if I said that right or not. AHB and BHD are a linear pair. Notice, yeah. Those two angles add up to a straight line. They are supplementary angles to one another. They add up to 180 degrees because they lie on that line. They showed us what that line was. BHA is congruent to CJA. BHA, this angle right here, is congruent to CJA, this angle right here. Again, we have ways to maybe prove that given other things. If we knew these lines were parallel, we could talk through later in the course how to show that those are congruent. But without knowing anything about these angles in here, without knowing anything about whether these lines are parallel or not, we cannot assume that those two angles are congruent to each other. angle AHF. AHF is this angle right here, and BHD are vertical angles, that angle right there. We defined vertical angles as being opposite one another on two intersecting lines. So we have two intersecting lines. Those are on opposite sides directly across from each other. Yes, those are vertical angles based on the definition of vertical angles. A, H, J, and D, A, H, J, and D are collinear. Notice they show them on the same line. They show that this line extends forever and passes through each of those points. Yes, we can assume that. AD is this line here that I just highlighted, and BF intersect at point H. And that sure shows that on here. Yes, that can be assumed and is true. So this section was making sure we understand those postulates that are given all on the front side, as well as understanding if I'm given a figure, what can I say is definitively true or might be true based on the figure. We can only assume things that are definitely given to us in the problem. That's it for the notes. Reach out if you have questions.